Hello students, hope you all are fine and safe and healthy and doing good in studies. Students, as vector is one of the most important chapter of physics, therefore I come up with this video in which I have discussed or I summarized the chapter in short. It covers almost all the points and formulae which is useful in your upcoming chapters. So, pay attention here. Okay, today we are going to study vectors and its types, addition of vector, Cartesian form of vectors, multiplication of vectors, and resolution of vectors. First of all, you know these things, scalars and vectors. Students, you know that scalar quantities has only magnitude, whereas vector quantities has both magnitude and direction. Here are some of the scalar quantities like length, area, volume, speed, mass, density, pressure, temperature, energy, entropy, work and power. All these are scalar quantities because they don't have any direction, they have only magnitude. On the other hand, vector quantities, displacement, velocity, acceleration, momentum, force, lift, drag, thrust and weight. These are some of the examples of vector quantities. Now, in this chapter, we have focused on only vector quantities. You already know that velocity is a vector quantity because it has magnitude and direction like 20 meter per second in north. So, direction and magnitude. Similarly, acceleration, force, this is example. And students, you know that we always represent vector by its symbol and with this arrow. So why we put this arrow? The arrow above the symbol. This arrow is used to convey direction and magnitude. So whenever you are going to represent a vector, you have to put its symbol with an arrow. So this is the pictorial representation of a vector. Now, different types of vectors. Number 1, zero vector, or it is also called null vector. It is represented by 0 with an arrow. Next vector is collinear vector. Here you can see the example of collinear vector. You can see these vectors are in a line. Next vector is unit vector. This is one of the important vector, unit vector. It is represented by its symbol with cap. This is the symbol of unit vector and it is always equal to vector divided by its magnitude. Here you are going to study I, j, k vectors. These all are the unit vectors. Alright? Okay. Next vector we are going to discuss is concurrent vector or co-initial vector. See, there are number of vectors here. C vector, E, A, D, B, they are starting from the same point. Such kind of vectors are called concurrent vectors or co-initial. Initial point is same, co-initial vectors. Next vector, equal vector. You can see this is the example of equal vector. Okay, these two vectors are equal vector because they are in the same direction with same magnitude. Next vector, coplanar vector. All these vectors are mostly coplanar vectors because they are on the same plane. Next, negative vector. Like here you can see negative vector in the opposite direction. These vectors are called negative vector. Then anti-parallel vector. If two vectors are opposite to each other, they are called anti-parallel vector like this. These are also called unlike vectors. This is anti-parallel vector. Next vector is position vector. Any vector which represents the position of a vector is called position vector. Then is the parallel vector. Two vectors which are parallel to each other. They are also called like vectors like AB. It's not necessary their magnitudes are same, but they should be parallel. Such vectors are called parallel vectors. Okay, now addition of vectors. How you can add two vectors? Students, whenever you have to add two vectors, there are two basic laws you have to follow. First law is the triangle law of vector addition. Now, what is triangle of vector addition? when two vectors are joined head to tail. This is head and this is tail. If this arrow represents the head of a vector, this endpoint is the tail of the vector. Here this is first vector and this is second vector, and these two vectors are joined head to tail. Draw the resultant vector by completing the triangle. If you want the resultant, what is the net result of addition of these two vectors, what you have to do, you have to draw another vector by completing the triangle in opposite direction. You are not going to draw like this. You have to draw opposite to these two vectors. This law is called triangle law of vector addition. Second law is the parallelogram law. Now when two vectors are joined tail to tail, here again number 1 and this is number 2, two vectors, they are joined tail to tail. Then complete the parallelogram, draw or construct parallel lines opposite to the vectors, you will get a parallelogram. The result is found by drawing the diagonal. Then what is the resultant? The resultant will be the diagonal of this parallelogram. Okay. So there is a brief description of triangle of vector addition. What you have to do, you can see here, two vectors A and B, they are joined head to tail, and then this R represents the resultant. So there are the steps we have to follow if you find the resultant. Otherwise you have to learn only the result, how you can find the resultant of this vector, its magnitude. Remember, you have to do a square, this vector square, plus b square plus 2ab cos theta under root. This is the resultant of these two vectors a and b. This formula you have to use when you have to add two vectors. Alright. Next, parallelogram law of vectors. Here again you can see these two vectors P and Q, they are joined tail to tail here. Then what we have done? We have done construction of a parallelogram, and see here alpha, this alpha is the angle between Q and P, and theta is the angle which R, this resultant, makes with the P. And how you come to know whether this theta is between Q and R or R and P? Always remember, you have to take the smaller angle. Alright. If it is 30 degree, this angle obviously less than or more than 30 degree, then you have to take theta with this P. Alright. So again, resultant is same as we have done in triangle law. You have to take p square, first vector square, second vector square, plus 2pq cos alpha under root. And to find the direction of the resultant, you have to use this formula. Theta is equal to tan inverse of q sin alpha divided by p plus q cos alpha. So this is the method to find the direction of resultant of the vector, and this is the resultant, magnitude of resultant. Remember, magnitude means value of the resultant of two vectors when you are going to add them. Okay. Now what if you have more than two vectors? Then you have to follow polygon law of vectors. Polygon, many angles, many sides. So polygon law of vector addition states that if number of vectors can be represented in magnitude and direction by sides of polygon, if you are representing these vectors as the side of this polygon, like A, B, C, D, these vectors can be represented as the side of polygon like A, B. We have not changed the direction. Keep this thing in mind. We have just taken this vector as it is. We are not changing its direction. If it is in the upside, here it is also on the upside. Here it is in this direction. We have taken C in the same direction. So we are arranging like a polygon taken in the same order. Then the resultant is represented in magnitude and direction by closing the side of the polygon taken in opposite order. Then you have to take this resultant by closing the polygon in opposite direction. So this is the resultant of the vector, which will be the sum of A vector plus B vector plus C vector plus T. Okay, After having the pictorial representation of vectors, let's come to another representation of vector, that is Cartesian representation. Now, what is this Cartesian representation of vector? Students, suppose I am going to draw a point here. This is the point I am going to draw here. And if I ask you what is the position of this point in this 3 coordinate system, then you can tell me that it is some distance away from x-axis, and it is y distance away from y-axis, and z distance away from z-axis. So a Cartesian system gives us the complete address of this position vector or this point. Alright, because it contains all the information that how much away is it from x-axis, y-axis and z-axis. As you know, I, j and k cap, all these are the unit vectors. This tells the direction, and fx, fy and fz are the vector components. Now how you can find these vector components? Just by using this formula. Vector component fx is equal to magnitude of f into cos theta. If I am taking an example of f vector is equal to fxi plus fyz plus fzk. It can be a vector is equal to axi plus ayj plus azk, but here we are talking about f vector, a journal vector. Alright. Now fy is equal to magnitude of f cos theta y, angle with the y-axis. Fz is equal to f magnitude of f cos theta. Now, how you can find the magnitude? It's easy. You can find the magnitude. Already we have done, but I am repeating here. F modulus magnitude of f is equal to under root fx square plus fy square plus fz square. Let us take an example. Suppose f vector is equal to 4i cap minus 3j cap plus 2k cap. Remember, cap should be there just due to typing somewhere. They have not typed cap here, but cap is always there. Alright. Now how you can find its magnitude? Magnitude is equal to, see the formula, fx square. Here 4 is fx, minus 3 is fy, 2 is fz, right? So 4 square, fx square, fy square plus fz square. So 4 square plus 3 square plus 2 square under root comes out to be 4 square 16, 3 square 9, 2 square 4, and the answer is under root 29. This is the way you can find the magnitude of any vector. Alright. Now next is directional cosines. It also tells the directions in cosines. So simply you have to do, if fx is equal to modulus of f or magnitude of f into cos theta, then cos theta will be fx upon f magnitude or mod f. Just you have to take this to the denominator. Alright, these all are called the directional cosines. And remember one trigonometric identity, all these direction cosines, if you are squaring it and adding it up, it will give you answer unity. Alright, this is the journal formula you have to learn. Okay, now what is the benefit of this Cartesian system or Cartesian representation of vector? One thing, you can find out the exact position of the point. Secondly, same rules are there. Remember, process is essentially the same as when 2D vectors. If you are going to add vectors in 2-dimensional or 3-dimensional, rules are going to be same. For example, if you have a vector A, axi plus ayj plus azk, and another vector B is equal to bxi plus byz plus bzk, then if you want to add these two vectors, it's very easy. No triangle law, no parallelogram law, no polygon law. What you have to do? You have to take the same coefficients and you have to add them. Ax plus bx, alright, with I as the common, plus ay plus by j, because j components are same. Add the k component, then az plus bz into k. This will give you another vector. Okay. Similarly, you can do a minus b. What you have to do? You have to subtract bx from ax, ay minus by, az minus bz. Alright. Now for example, if we have two vectors, a vector is equal to 2i plus 3j minus 2k and b vector is equal to 5i plus 2j minus k, then a plus b will be this 2 and here I component is 5, 2 plus 5i plus, come to the next, that is 3, here plus 2, 3 plus 2, j, next come to k component, minus 2, and in the last here it is minus 1. Alright. So it comes out to be 2 plus 5, 7i plus 3 plus 2, 5j minus 2 minus 1, minus 3k. This is the resultant of a plus b. Okay, this is the addition of Cartesian vectors. Now after addition and subtraction, next is multiplication of vectors. Students, multiplication of vectors is very important. There are two kinds of multiplication in vectors. One is called the scalar product or dot product. Second is vector product or cross product. Now the result of the scalar multiplication of two vectors is scalar. If you are going to multiply two vectors and the result is scalar, then such kind of product is called scalar product. This is the formula you have to keep in your mind. What is the formula? If there is a vector and b vector, always remember dot product is represented by putting dot between two vectors and the answer will be ab cos theta or cos phi. Here if angle is phi, you can take phi. Now there are scalar products of unit vector. Obviously unit vector I, j and k. What are the results? Some standard results are there, you have to keep in mind. Remember I dot I is always 1 because what is the magnitude of I? 1. Magnitude of I again 1. And what is the angle between I and I? I and I both are in x direction. So angle between I and I cap is 0 degree. So answer will be 1. So keep this result in your mind that I dot I is equal to 1. J dot j is equal to 1. K dot k is equal to 1. Means dot product of unit vector with itself is always 1. On the other hand, I dot j with any other unit vector, I with j, I with k, j with k, k with I, the angle between two unit vectors is always 90 degree. Okay, magnitude of I is 1, magnitude of j is also 1, but the angle between these two vectors is 90 degree. Because if you remember that diagram we have just seen in the previous, there are two x, y and z. Okay, like this. This is x-axis, this is y-axis and this is z-axis. So I represent x, j represent y and k represent z. Angle between all these coordinates are 90 degree. So cos 90 is 0. Answer will be 0. If you are going to take dot product of any unit vector with the other one, answer will be simply 0. Okay, this is scalar product or dot product. Now the vector product, which is also called cross product. Why? Because it is represented by cross between two vectors. The cross product of two vectors says something about perpendicular they are. Its magnitude is a cross b and the formula is ab sin theta. See the difference here, ab cos theta and here it is ab sin theta. Theta is the smaller angle between the vectors. If these two are the vectors, this is a vector, alright. This is suppose a vector and this is b vector. Always you have to take the smaller angle because you can take two angles. You can take this angle also or you can take either this angle. But what does the rule says? Rule says that you have to take the smaller angle and a cross b means you have to take a to b. If it is b cross a, then you have to take b to a. Okay, direction matters in vector products because result of vector product is a, another vector. You will get again another vector c. Cross product of any parallel vectors is always 0. If two vectors are parallel, you are going to take cross product between their two vectors, the answer will be 0. Alright, here is the complete rule. Just see. First of all, write I, J and K. In the previous screen, you have seen that I, J and K, but it is more convenient to take I, J, K, and this is in clockwise direction. You are going to move in clockwise direction, then I cross J will give you K vector. Here you can see I cross J will give us K vector. J cross K will give you I vector next. Alright, and similarly K cross I will give you next vector, that is J vector, when we are going in clockwise direction. Remember the direction also. But if we are going to change the direction, the sign will be changed. For example, if I use K cross J will give me I vector. Okay, K cross J will give me I vector, but in negative sign. You have to put the negative sign. J cross I will give us K with minus, because we are going in opposite direction. I cross K gives us J vector in minus. Alright, these are the results. And if we are going to take I cross I, 0, J cross J, 0, K cross K, 0. So if we get another vector after multiplying or after doing cross product of A and B, third is the answer is also a vector, then it must have magnitude as well as direction. So how you can find the direction of the resultant vector of A cross B? For that you have to follow right hand thumb rule. What is the rule? Curl the finger of right hand in such a way that they point in the direction of rotation of the vector from A to B. If you are going to find A to B, A cross B, if it is A and it is B, you have to do A cross B. Then through the smaller angle, keeping the thumb erect. I told you already, you have to take care of smaller angle. Then the thumb will point in the direction A cross B. Then the resultant, whatever the resultant you will get, this thumb will represent the resultant direction or direction of the resultant vector. Like this is I vector, this is J vector. I cross J will gives us the third vector K, which is in the direction of thumb. Alright. Now, if you see in this calculations, what you have to do? A cross B. A vector has 3 components, B vector also has 3 components, I, J, K. What you have to do? You have to multiply first component with this BI, then again this, like mathematical rule you are doing in while opening the brackets, same rule you are going to follow here. Then again I with K. Okay, then in the next step you have to multiply J one by one, and ultimately you will get this result. So it is quite a complex one. For solving numericals, we will usually prefer to use this method. This is called determinant method. What we will do? If A is a vector, AI plus A2J plus A3K, and B is another vector, B1I plus B2J plus B3K. These are the two vectors, and you have to find A cross B. Remember the position of A and B. If A is written first, A cross B, then you have to take care A components firstly. Now what you have to do? You have to put 2 lines. This is called determinant, and you have to first of all write I, J, K on the top row. Alright. Then you have to write, if A is in the first number, then you have to write the components of A here. A1, A2, A3. Then B, B1, B2 and B3. Then there is a rule that I you have to take positive, and for J negative, and for K again positive. This is the rule. Now what you have to do? First, for write I here. These are the steps of calculating cross product of two vectors. It's important. Just see I here. Now leave this column and row. So what we are left with? A2, A3, B2 and B3. Now what you have to do? You have to go from the first number. A multiply by B3. Alright. A2, B3. Done. Then in between you have to put minus. This is the rule. Minus. Then from the top, A component first. A3 multiply by B2. A3, B2. Done. Then this is the I component, first part we have done. Next, I told you put minus here with J. Now this time what you have to do, you have to eliminate J line and this. Alright, we are left with A1, B1, A3, B3. So what you have to do, first start from the left side. A1 multiply by B3, then A minus as usual, then A3 multiply by B1 here. And similarly for the last K, leave this line and this row and multiply A1 with B2 minus A2 B1. So this is the result, which is your resultant vector. Alright. If you are getting confused, let's take one example. Given U is equal to I plus 2j plus k and V is 3i plus j plus 2k. Find the cross product of U and V. You have to find U and V cross product. First of all, I, j, k, right on the top. For I, you have to take plus, j minus and k again plus. Alright. First, what are the coefficients of I, j and k? I 1, j 2, k 1. For V, 3, j 1, 2. Alright. Why we have written U 3 afterwards? Because U cross V. First you have to write the values of U and then values of V. Okay. Now I, you have to take this part 2, 1, 1, 2. Okay. Minus as usual. For J, leave these lines and rows. We are left with 1, 3, 1, 2. 1, 3, 1, 2 J. For K plus. Okay. Leave these two lines. We are 1, 3, 2, 1. 1, 3, 2, 1. Alright. Now what you have to do? First of all, from left to right. 2 into 2. 4. Minus. Compulsory. You have to put always minus. No plus here. Minus 1 into 1, 1, right, minus 1 into 2, 2, 1 into 3, 3 with minus j, plus 1 into 1 again 1, minus sign as it is, 2 into 3, 6, then the result will be 4 minus 1, 3i, 2 minus 3, minus 1, minus 1, minus 1, plus 1, plus j. Here 1 minus 6 minus 5k. So this is the resultant of U cross V. Alright. Now what is the difference between a dot product and a cross product? If the product of two vectors is scalar quantity, the product is called scalar product or dot product. If you are going to multiply and you get a scalar result, means it's a dot product or a scalar product. And if the product of two vector is vector quantity, then the product is called cross product or vector product. The dot product is defined by the relation. The formula for dot product is A dot B is equal to AB cos theta. Cross product is defined by the relation A cross B, AB sin theta. Scalar product obeys commutative law. What is commutative law? That if you are going to multiply A dot B, it is always equal to B dot A. It doesn't matter you are multiplying, taking product A dot B or B dot A. The vector or cross product does not obey commutative law. Means A cross B is not equal to B cross A. If two vectors are perpendicular to each other, then their scalar product is 0. It is very important identity to prove that two vectors are perpendicular to each other, that their dot product should be 0. if you are getting a dot product 0, it means that these two vectors A and B are perpendicular to each other. This is called condition for perpendicularity. It is important. Most of the questions come on these conditions only. If two vectors are parallel to each other, their vector product is 0. And if two vectors are parallel, then cross product is 0. If you are going to take multiply two vectors and you are going to take cross product of these two vectors and your result is 0, means that A and B are parallel to each other. So this condition is called condition for parallelism, right? Now, after finding the magnitude of a vector, you have to find sometimes angle between two vectors. Now, how you can find angle between two vectors? Suppose A and B vectors are at certain angle, let it be theta, and you are asked to find this angle, then what you will do? If you remember dot product, you are going to use this dot product result, that A dot B is equal to magnitude of A multiplied by magnitude of B into cos theta. Now if I take cos theta at one side and I will make this A dot B to the denominator of A dot B, then I can get the cos theta like this. Cos theta is equal to A dot B magnitude of A into magnitude of B. I want this theta. Okay, I know that theta is equal to, I can take cos to the other side, it will become cos inverse of A dot B upon magnitude of A into B. For example, A vector I plus 2j minus u, B vector 4i plus j minus 2u. Here you can write k also. We have done k, I, j, k. Standard form is k only. Okay, now A dot B is equal to AB cos theta. This is the relation. So how you can find A dot B? Simply you have to multiply I component with I component of another vector. So it comes out to be 1 into minus 4, minus 4. 2 into 1, plus 2. Minus 1 into minus 2, plus 2. And answer is 0. Okay, if this A dot B is 0, what does it mean? Cos theta is equal to 0, because 0 divided by anything obviously give you a 0 result. And cos theta 0, it means theta is 90 degree. In this way you can find the angle between two vectors. Okay. Find the direction cosines of vector f vector is equal to 4i minus 3j plus 2k. How you can find the direction cosines? First of all, you have to find magnitude of this vector. Already we have done this. Alright, but we know that direction cosines are also equal to these relation we have done just now. So what you have to do? Direction cosines. You have to take fx, this 4 divided by under root magnitude 29, for y minus 3 upon under root 29, and last for z 2 under root 29. Okay, last is resolution of a vector. Now if you are given with a vector, you have to resolve it. What is the meaning of resolution of vector? Means to find the horizontal and vertical component of a vector. Alright, if you are given with one vector, this is the vector randomly in a space, and if you are told to resolve it or find its horizontal and vertical component, then we call it resolution of a vector. Always remember, if r is a vector, it is making theta with angle with the horizontal component. So always this, wherever this theta is, that will be cos theta and another will be sin theta. So if r is the resultant vector, then horizontal component is r cos theta and vertical component is r sin theta. And we'll take one example. Suppose you are pulling a dog through a chain making an angle theta, alright, and you are applying force of 60 Newton. So resolution of vector means how much horizontal force and vertical force is applied on it. So for horizontal, I told you horizontal, you have to take cos theta. So what is the formula? That r cos theta, this is the horizontal component, r h. Okay. Horizontal component means how much force or acting on horizontal direction. It is equal to resultant r multiplied by cos theta, cos of angle between this horizontal component. And this r sin theta is equal to r vertical. This is the vertical component, is equal to r v. Okay, let us take an example. If you are pulling a dog with a force of 60 Newton at an angle of 40 degree and you are asked to find horizontal and vertical component, so what you will do? By using the directional cosine formula. Alright, so cos theta, this horizontal, for horizontal component you have to take cos theta. Cos theta is equal to f horizontal divided by magnitude of this resultant. Alright, here it is given 60 Newton, we are going to divide with 60 Newton. So what is the value of f horizontal? F horizontal is equal to, this is going to be multiplied with cos 40 degree and we got the answer 45.9 Newton. Now for vertical component, already explained, vertical, for vertical component you have to take sine. So sine theta is equal to f vertical upon magnitude of force, again 60 Newton. Again we will cross multiply it, f vertical is equal to 60 Newton multiplied by sine 40 and the answer will be 38.6 Newton. So these are the vertical and horizontal component of a vector 60 Newton. Alright, this is called resolution of a vector. These are the important points and important terms you should keep in your mind while studying the vectors. Now you are able to answer these questions like distinguish between scalar and vector quantities, give examples. Why do we put arrow mark while representing a vector? Find the unit vector of the vector r is equal to 4i minus 2j plus 3k. What is the condition of perpendicularity of two vectors? How will you find direction of the vector product of two vectors? You have to tell how you can find, the rule you are going to follow. What is the condition of parallelism of two vectors? The vector product of two vectors is a zero vector. What does it imply? A cross B is not equal to B cross A. Why? The vertical component of a force acting at 60 degree to the horizontal is 8.48 Newton. You are given with the vertical component and the angle with which it is making with the horizontal component is 60 degree. You have to find the force and the horizontal component. This numerical you are going to solve with the help of resolution of vector. That's the end of the topic. Thank you.